Hello, everyone. Today, we'll talk about algebraic operation on fractions. Before we talk about the operation, we first introduce fraction numbers. Suppose n is a non-zero natural number, such as 1, 2, those kind of number. We define its reciprocal. We write it 1 over n as a unique number. This unique number satisfies 1 over n times n equals to 1. Since the multiplication has cumulative rule, we also know that n multiplied 1 over n is also equal to 1. Once we introduce the reciprocal number, we now introduce a fraction. Now suppose n and m, both of them, are non-zero natural numbers. We define this fraction m over n essentially as m copy of 1 over n. Here we write down m on the top, call it numerator. N at the bottom will be called denominator. Let's try to figure out what's the real meaning of that. Suppose m is divisible by n. For example, I give you an example here. The 18 over 3. What's the real meaning of 18 over 3? Now, first of all, 18 over 3, by definition, just 18 copy of 1/3. And 8 actually is divisible by 3. So I write it as 6 times 3. So therefore, this is 6 times 3 times 1/3. And since multiplication has associated rule, we can operate on 3 times 1/3 first, which gives you 1 due to the definition of reciprocal. Therefore, the final answer is 6. Yes, 18 over 3 is essentially just 18 divided by 3. So later, whether this m is divisible by n or not, we always write down the division m over n by m over n. Okay, so m over n, the same as m divided by n. Okay, which is m copy of 1 over n. Okay, after we introduce the fraction, we look at the how to do the algebraic operation, meaning multiplication, division, addition, and subtraction. Now here, let's assume this k, l, m, n, all these 4 numbers are non-zero natural numbers. We first try to understand this easy multiplication. 1 over m multiplied 1 over n equal to 1 over m times n. Why this is correct? Well, actually, it's easy to check. 1 over m multiply 1 over n multiply n times m, this number. Using commutative rule, we have 1 over m multiply m, and then we have 1 over n multiply n, because you can commute, right? And then we're using so-called associative rule. You can basically multiply these two first and multiply the last two second. Then using definition of reciprocal, the first one, 1 over n times m is 1. 1 over n times n is also 1. Therefore, that equals 1. This means that this n times m, this number, reciprocal is exactly 1 over m times 1 over n. On the other hand, we do know 1 over n, we do know n times m's reciprocal is 1 over n times m. That means that this 1 over n times m, the reciprocal of n times m, actually is same as 1 over n and 1 over n. That's basically proof of this easy formula. Now, to understand the general multiplication rule, this one, the idea is quite similar. So essentially, we can do the following things, because L over n actually is L copy of 1 over n. K over m is k copy of 1 over m. Then using the commutative rule, we have L times k multiply 1 over n multiply 1 over m. Then using associative rule, you have L times k parentheses multiply, we use above property. This 1 over n times 1 over m actually is 1 over n times m. Then using definition of fraction, this is exactly the same as Lk over Nm. Thus, we obtain a general multiplication rules. Using this general multiplication rule, it is relatively easy to calculate the reciprocal of a fraction m over n. So for instance, if you look at the reciprocal of this number m over n, right, you can check pretty easily that m over n multiply n over m is exactly equal to m times n over n times m, which equals 1. Therefore, the reciprocal of m over n just flip these two numbers, change the position. The numerator becomes denominator. The denominator becomes numerator. So that is the reciprocal of m over n. So as we said, whenever we divide something, essentially as just multiply its reciprocal. So the division rule is relatively easy. Say L over n divided by k over m. So this is the same as L over n multiply the reciprocal of k over m, which is m over k. Then we're using multiplication rule. We have the final result is L m over n times k. So that covers the multiplication rule and the division rule for fractions. Finally, we talk about the addition rule. So suppose we have two fractions which have the same denominator, k over m and L over m. If we want to add them together, we can do the following things. So k over m is k copy of 1 over m. L over m is L copy of 1 over m. Then the multiplication has so-called distributive rule. So totally we have k plus L parentheses multiply 1 over m copy. So we have k plus L copy of 1 over m. Therefore, by definition of fraction, that is k plus L over m. We summarize as this rule. Generally, people say, as long as you have the same denominator, you add numerator together. Here, we give the reason. Now, suppose two fractions have different denominators. Here, we have k over m plus L over n. So the way to do that is the following. We do log k over m, same as k over m multiply 1. Of course, L over n, same as L over n, multiply 1 also. And the first one, k over m, we can write it as multiply n divided by n. Second one, we can write it as L over n multiply m divided by m. And therefore, we have, so this is a addition, sorry about that. So we have basically k times n plus L over m. And I have the same denominator, which is n, m times n. This is summarized as the second addition rule. So addition rule a little bit more complicated than the multiplication rule of fractions. So we covered all the algebraic rule for fractions, and I hope you enjoyed, and I'll see you next time.